given that probability can be thought of as the chance that some event or events will or will not occur, we can think about probability in terms of two different types of scenarios. We have and scenarios, and so that would be the probability that event A and event B both occur. And then we have or scenarios, and so that would be the probability that event A or event B occurs. But before we can talk about any of those two things, I should probably preface everything we're about to talk about, not just for this video, but for the remainder of this video series, by saying for all of the questions we are going to do, we are going to assume that we have independent events, because overwhelmingly so, those are the type of probability questions that the GMAT will ask you. I think I have only seen one question that gave you a scenario where you didn't have independent events. And so if you don't have independent events, you sort of have to forget a lot of what we are talking about here, and that's an entirely different ball game, and you have to approach it differently. And so what do I mean when I say independent events? And so the classic example that the GMAT likes to use is coin flips. So coin flips usually are independent of each other, meaning that the outcome of one coin flip should have no impact on the outcome of the second coin flip. They are random. In other words, no matter what, the probability of getting a heads on any coin flip is 50%, and the probability of getting tails on any given coin flip is 50%. And a lot of times they'll even further sort of specify that you have your events are independent by saying if you flip a fair coin or if you flip a regular coin. So they're specifying that your coin is not rigged, and you really do have the probability that you would expect to have when you flip a coin. And so if your coin flips are independent, what that means is, even if I were to tell you, you flipped a coin 5 times, every single time you got heads. Then I was to ask, what is the probability of getting heads again on your 6th coin flip? Well, given that your coin flips are independent, it would still be 1/2. So even though it might seem like your probability should be higher than 1/2, given that you got heads for every other coin flip, that is really just a coincidence. And if it is in fact a fair coin, your probability of getting a head on your 6th coin flip is still 1/2, because the fact that you got all heads here has no impact on the probability of getting a heads here. And so that is what they mean by independent events. Dependent events would be something like stocks, maybe, for example, where they might tell you that stock A has a 40% chance of going up and stock B has a 30% chance of going up. However, with stocks, it's also possible that those two stocks are correlated with each other, meaning they are dependent events. Meaning once you know that stock A went up, that might affect the probability that stock B will go up. And so even if they tell you overall stock A has a 40% chance of going up and stock B has a 30% chance of going up, once you know that stock A has gone up, that might change the probability for stock B. And so they would have to tell you what is the factor by which those two stocks are correlated before you could answer that question. But like I said, more often than not, they will give you independent events, and that is what we will talk about. So, what does it mean to have an and scenario? And so most people, if we go back to our coin flip example, think of and scenarios as meaning that's when you multiply your probabilities. And so if I was to say, what is the probability of getting, you flip a coin 3 times, what's the probability of getting heads? Well, all 3 times? Well, you have a 50% chance of getting a heads on your first coin flip, a 50% chance of getting a heads on your second coin flip, and a 50% chance of getting a heads on your third coin flip. And because and means multiply, you gotta multiply 1/2 times 1/2 times 1/2 to get a 1/8 chance overall of getting a heads on your first and your second and your third coin flip. So and scenarios, these are the easy ones usually. Now, the ones that confuse people sometimes are or scenarios, because first, sometimes people just think or and means multiply, or means add. That can get you into a little bit of trouble if you don't really understand what you're doing. Because say I was to ask, what is the probability of getting heads on the first or second coin flip if I flip a coin 2 times? Well, if you were to say, oh, or just means you add your 2 individual probabilities, that would mean I have a 1/2 chance of getting a heads here, plus another 1/2 chance of getting a heads here, to give me a 1 or 100% chance of getting a heads overall, which of course does not make sense, because it's possible that I could get 2 tails, so I can't have a 100% chance of getting a heads on the first or second coin flip. So why is that? And the best way to illustrate why this is not right is with a Venn diagram. And so here I have 2 circles. The green one represents the probability of getting a heads on your first coin flip. The blue one represents the probability of getting a heads on your second coin flip. And then in the middle here, we have, this is our shared probability. So this is the probability of getting a heads on both your first coin flip and your second coin flip. So if I was to say, what is the probability of getting a heads on my first coin flip? Well, that is 1/2. Then I would say it's an or scenario, so I want to add the probability of a heads on your second coin flip. So that is also 1/2. And so then what I've done so far is I've added my green circle to my blue circle. And that is how we got our probability of 1. But what is the problem with what we did there? It comes down to this middle section. So in other words, when I counted my green circle and when I counted my blue circle, each of those times I counted this middle section. Now, how many times do I want to count it? You still want to count it once, right? Because if I'm talking about the probability of getting a heads on my first coin flip or on my second coin flip, I still want to include the chance that I get a heads on each of my coin flips. That still should be counted in my or scenario. But in this case, we counted it twice. So we have to take it out. And how many times do we have to take it out? If we counted it twice, we still want to leave it in once. So we got to take it out once. So this should be 1/2 plus 1/2 minus the probability of getting heads on both. That would be 1/2 times 1/2. And so this ends up being 1/2 plus 1/2, which is 1 minus 1/4, which is 3/4. And this makes more sense. So I have a 75% chance of getting a heads on my first or my second coin flip. And that is why, so the formula that people really should be remembering for or scenarios is probability of event A occurring plus the probability of event B occurring minus the probability of them both occurring. Now, I don't love this formula because I don't think it's super logical. It's not super intuitive. This is sort of a weird approach for solving any sort of problem where you purposely double count something and then subtract out what you double counted. And plus, it's not going to represent every scenario. In other words, here we would use this formula. because our two events, heads on our first coin flip and heads on our second coin flip, they are not mutually exclusive. Both of those two things can occur. However, not all scenarios are like that. And so let's say I had a scenario, if I wanted to know what is the probability that Bobby or Sally comes in first place. Well, in that case, my Venn diagram looks like this, right? And this here would be my probability of Bobby coming in first place. This would be Sally. But there's no overlap because it is not possible for both Bobby and Sally to come in first place, assuming there are no ties. And so in this case, my events are mutually exclusive, and I can represent my OR scenario just like this. I don't have to subtract out anything because there is nothing to subtract out because there is no overlap between our two scenarios. So the way I usually think of OR scenarios, so that I don't have to think about this Venn diagram or do I have to subtract anything out. The way I do that is usually I just think about my events in terms of the sequence of events as a whole rather than my individual events. In other words, so if I had the same question of what is the probability of getting heads on my first or my second coin flip, instead of thinking in terms of the probability of my individual events, getting a probability here, getting a probability here, I'm thinking in terms of my entire sequence. So what are the ways I can get a heads on my first or second coin flip? Well, I can get a heads here and a tails here. That's one scenario. I can get a tails here and a heads here. That's another scenario. Or I can get a heads on both. That's my final scenario of how I can get a heads on my first or second coin flip. And now, because if I'm thinking in terms of my sequence as a whole, what am I really doing here? I'm ensuring that all of these events are mutually exclusive, right? Because even though I can have a heads on my first or my second coin flip or both, I can't have any two of these scenarios occur. I can't both get a heads on my first and a tails on my second, and also get a tails on my first and my heads on a second. So by eliminating having to think about my events individually, I'm ensuring that my OR scenarios are always mutually exclusive, and therefore I never have to subtract anything. And so now really what I'm doing is I'm just saying, so what is this probability? So each of my individual scenarios is an AND scenario, right? So this is going to be 1/2 times 1/2, which is 1/4. This will be 1/2 times 1/2. So this will also be 1/4. This will also be 1/2 times 1/2, which is a fourth. And now I can say, even though individually they're AND scenarios, I can get a heads in my first or second coin flip this way, or this way, or this way. And I have a 3/4 chance overall. And so whether you sort of do them based on the formula, or just sort of based on logic, which is how I do them. And the way I do that is by thinking about things in terms of the entire sequence as a whole. Either of those should work. This is my preference because I prefer to do things based on logic rather than memorization. But this should work just as well, as long as you know you only need to do this. You only need to subtract out your events that you double counted when you have non-mutually exclusive events that can both occur together. So something like coin flips, you can get a heads on your first or your second or on both. But in a scenario like a race or something, two people cannot simultaneously come in first place. And so this would be mutually exclusive. Therefore, I don't have to subtract out anything. this here is not mutually exclusive. And that is why there is overlap. So that is your intro to and or scenarios. In the next video, we'll do a problem using what we've learned here.